Alright guys, today we're going to start looking at compound probability, target 4B. So, for compound probability, you're really defining the probability of a compound event. And a compound event is just an event that is made up of two or more events. So, if I'm doing like, oh, I want to find a probability of, choosing a blue marble and choosing a green marble, or choosing a blue marble or choosing a green marble, right? So, it's kind of things that are made up of and or. And when we have compound events, we can either have an independent event, right? So that means the occurrence of one event does not affect how another event occurs. So, for example, if I'm trying to think of something here, if I choose again like a blue marble, and then let's say I choose something from a deck, choose a card from a deck of cards, right? Those marbles in that deck of cards have nothing to do with each other, so those will be independent events. If two events are independent, I can find the probability of both of those things happening, right? So like that would be and, I'm going to find this and that, by just multiplying those two probabilities. Okay, and we'll do some examples of that. If, events are not independent, then we call them dependent, right? The one depends on the other. So, for example, right, if the probability of it raining here in Berwyn and the probability of it raining in Chicago, right? Those two places are so close that the probability of one and the probability of the other are probably linked in some way. They're not independent. Or if I pull a card out from a deck of cards, and then without putting it back, I pull another one, right? Since I removed one of the cards, right, now when I take the second one, my chances have changed. One of those cards is gone. I can't choose that one anymore, right? So some things like that are independent and dependent. Okay? So that's mostly what we're going to focus on today. All right, so let's look at, sorry that jump. Let's look at these examples. Use this figure again. There we go. There we go. Okay, so let's look at some of these examples. So example 1, we're determining if the events are independent or dependent. And in order to determine if events are independent or dependent, you're really looking at the sample space of the second one. Does it change after I do the first thing? Okay? So, my event A is choosing a number tile from 12 tiles. That's event A, we'll say. My event B is spinning a spinner. Okay. So if I look at, so spinning a spinner is event B. So I want to say, okay, before I do anything with event A, how many options do I have for event B to happen? So for that, right, we don't really know how many spots there are on a spinner, but we'll just pretend. Right, let's say there's 6. Okay, let's say our spinner has 6 different spots. So when we start, right, before I do anything, my spinner has 6 sections. Once I choose that number tile, has my number of sections changed? No, my spinner is still going to have 6 sections. Right? Since these two numbers are the same, right, since these two sample spaces are the same, this is independent. Alright, so that's kind of a nice way to think about it. Does my sample space of my event B change after event A happens? Okay, so looking at our next example, again, event A, pick one card from a set of 15 cards. Alright, that's A. My event B, my second event, is pick another card. So again, when I first do this, right, before I do anything, my second event, picking a card, would have 15 cards. Once I pull that card out, right, right? Once I do event A, I pull the card out. Now I only have 14 cards, right? It's weird. Then without replacing it, that's a weird comment there. Then without replacing it. So now I only have 14 cards, right? Now these numbers have changed. Okay? So for this one, it's dependent. And so that's the difference between your independent probability and your dependent probability. It's changed. All right, let's move on to look at example 2. You roll a standard die, then spin the spinner on the right. What is the probability that you roll a number less than 3 and the spinner lands on a vowel? Okay. So what are my two events? My event A, I roll a standard die into the spinner, right? What is the probability that you roll a number less than 3? Right, so that's A. And spinner lands on a vowel, that's B. So always know what your events are. So for the probability of A, I want to roll a number less than 3. Well, if I think about a standard die, I have 1, 2, 3, 4, 5, 6. Okay? So my numbers less than 3 are 1 and 2. 3 is not less than 3, so be careful with that. So I have 2 numbers out of 6 numbers less than 3, so my probability of A is 1 out of 3. Okay. Then I want to find the probability of B. Right? The spinner lands on a vowel. When we look at my spinner, the only vowel here is U. So that's 1 space out of 4 spaces on my spinner, which doesn't produce. So it's just 1 out of 4. So then the probability of A and B equals the probability of A times the probability of B, which equals, I have 1/3 times 1/4, which is 1/12. Right? So we're finding the probability of A and B, right? We're just multiplying. Okay? All right, moving on to example 3. Oops, sorry. So, example 3 says, a factory foreman determines that on any given day, there is a 15% chance that machine A will malfunction, a 45% chance that machine B will malfunction, and a 6.75% chance that both machines will malfunction. Are the events of machine A malfunctions and machine B malfunctions independent events? Well, the one thing we know is if they're independent, then the probability of A times the probability of B equals the probability of A and B. So I'm really just finding all this information and plugging it into there. So again, I need to know what A and B are. Well, my first one, right, is machine A malfunction. That's A. So the probability of A, it tells us, is 15%. We in math don't like really dealing with percents, so we're going to move that decimal back 2 places and say it's 0.15. The probability of B, right, well, event B is machine B malfunctions, right, and there's a 45% chance that machine B will malfunction. So the probability of B equals 45%, which is 0.45. Again, moving that decimal place back twice. And so then the probability of A and B, again, this is what it tells us. I'm not multiplying here. I know all 3, right? I'm seeing yes, it's independent, or no, it's dependent. Okay? So the probability of both, right, 6.75% chance that both happen, which is, again, moving that back twice, 0.0675. Okay. So now I'm just substituting these in. So I have 0.15 times 0.45 has to equal 0.0675. Okay? When I multiply those, I get 0.0675 equals 0.0675. So I can write a check there. Yes, these are independent. Since those are equal, we can say independent. Those are independent. All right, looking at example 4, the probability that event A occurs is 0.3, and the probability that event B occurs is 0.1. There is a 25% chance of both event A and event B occurring. Are the events independent? So again, event A, what is easy? Event A occurs at 0.3, so the probability. So the probability of A equals 0.3, and this is nice because it's already in decimal form. I don't have to change it. Event B occurring is 0.1. The probability of C equals 0.1. And then the probability of A and B, 25% chance to both occur. Right? So, probability of A and B equals 25%. This one I do have to change, right? That's 0.25. So then, right, I just have to say, okay, the probability of A times the probability of B has to equal the probability of A and B if they're independent, or in order for it to be independent. So I had 0.3 times 0.1 equals 0.25. Right? So 0.3 times 0.1 is 0.03. Right? Well, those are not equal. So these two events would be dependent. Okay. Alright, that's all we're going to look at. Most of what we were looking at today was independent events. Tomorrow I'll be looking at a few different types of compound events. Have a good day. I'll see you guys tomorrow.